laws of indices. We have some rules to follow. All right, I'll do an example on each rule. We are dealing with the blue first. So rules of indices. So the first one, I say if you're multiplying same letters or same numbers, you simply add the powers. If you're multiplying same letters or same numbers, you add the powers. So if I have, I'm going to work some example below here. So if I have, let me use blue to coordinate what I'm doing here. So if I have x squared times x cubed, so I'm multiplying same letters, so I add the powers. So I put, if I have a to the m times a to the n, I'm only writing a once, and I'm raising it to the power m plus n, I add any powers, right? So this is equal to x to the 2 plus 3, which is x to the power 5. Now, I don't want to go and prove it, right? That will make the video long. That's not the aim of this video, to prove it. So I'm just showing you based on the formula how you work it out, right? So same letters or same numbers when you're multiplying, you add the powers. So if I have 2 to the power cube multiplied by 2 to the power 1, the rule is if you're multiplying same letters or same numbers, you add the powers. So I'm following the rule. I put 2 once, right? And I'm adding the powers. 3 plus 1, that is 2 to the power 4. 2 2s are 4, 2s are 8, 2s are 16 is the answer. So one last little question. So if I have x to the negative 6 multiplied by x to the, let me use negative 2. All right, a little challenging question. Let's just see. Not really. So multiplying same letters. So we say x, you write down x once to the power negative 6 plus negative 2. All right, when you're multiplying different signs, it's a negative. So we have x to the negative 6 minus 2. And negative 6 minus 2 is negative 8. So we have x to the negative 8. All right, so that's it for the first rule here, for the blue, rules of indices. So let's look at the second one. Let me just erase this to get some room. Right, the second one. So this second one tells you if you're dividing same letters or same numbers, you subtract the powers. So going right into it, if you understand the first one, you know the second one is just like the opposite. So if I have x squared, not multiply, divided by x cubed, let's just say, since it's the same letters, we subtract the powers. This is x to the 2 minus 3, and 2 minus 3 is negative 1. X to the negative 1. This year, we're going to come to this later on, but I'm not going to touch it here. We deal with this question. This is the answer, right? This is the answer right here, unless they want it in a certain form. That's different, but this is the answer right here. So if I have 2 cubed divided by 2 squared, that is equal to 2 to the 3 minus 2, because I'm dividing, so I put 2 once, and I subtract the powers because it's division. 3 minus 2. 3 minus 2 is 1. 2 to the power 1 is equal to 2. Again, I can prove it, but the video will be extremely long, right? So I'm just trying to restrain myself from proving, right? Focusing on the formula alone. And the last question, let me just add some negatives. So let's say if I have 3 to the power 1 divided by 3 to the negative 2. Let's just see. This is 3 to the 1 minus. So this 1 is the first number. This minus sign is because you're dividing 2 same numbers. That's this minus sign. And then the next number that you have to write is negative 2. Some people might just write 2 and say, but look, I have negative 2 here. That would be wrong because this minus sign is because of the division rule, right? So you have to have negative 2. So you have negative 2, put that in a bracket. Try not to make that mistake. M is equal to 1. And n is negative 2. That's why I have negative 2 in a bracket. All right, this negative sign is because of the rule to divide. So we continue. We have 3 to the 1 plus 2, which is 3 cubed, because when you're multiplying, same sign is positive. 3 cubed, 3 3s are 9, 3 is 27. That's the answer right there. All right, so that's 2. Let's deal with 3 now. Let's deal with 3. We have a to the m in brackets n. So that is a to the m times n, so you're multiplying the powers. So if I have a to the m in brackets n, this is equal to a to the m times n. So let me give you a proper example. So, because you have to deal with everything. If I have 2x cubed to the 4, all right, let's say I have this question, it says simplify. So the first thing I have to note that, okay, this 2 is raised to the power 1. You have to know that it's understood. And then you say, okay, since we have this rule, we multiplying the powers. We are multiplying the powers. So we have 2 to the 1 times 4, x to the 3 times 4. We have to multiply both powers by what's in the bracket, what's outside of the bracket, right? So we have 2 to the 4th power, x to the 12. 2 to the 4th power is 16, x to the 12. That's the answer right there. Right, that's the answer right there. If I have to do another question, 3y squared squared. Let's just say this is equal to 3 to the 1 times 2, y to the 2 times 2, which is 3 squared, y 4, 3 squared is 9, y to the power 4. I just follow the rule and multiplying the powers. Okay. Let me erase this. So that's we dealt with the blue. Now let's look at this here, negative and fractional indices. So e to the negative n, 1 to the e over n. So this is what I like to say. If I have 2 to the negative 1, I'm thinking numerator and denominator. So if I see a negative, I will say that, okay, that is not the original position. So I say the original position for this is supposed to be the denominator because of the negative power. So I can rewrite this as saying 2 to the plus 1, because plus 1, which is equal to 1 over 2. Right? 2 to the plus 1 is 2. So the original position it's supposed to be is the denominator. So instead of writing it like this, I put it to the bottom. Right? So if I have 3 to the negative 1, let's just say, I will say, okay, the original position is denominator. So I put 1 over 3 to the power plus 1, or just put a third. Right? Now, yeah, let's show that there. Now, if I have this question, if I have, let's say I have 1 over 2 to the minus 1, then I will say, well, okay, the denominator is not really its original position because it has negative 1. So the original position has to be the numerator. So I will say this is equal to 2 to the plus 1. Right, so come like I bring it to the numerator and I change the sign to positive because this is not the original position due to the negative sign. Simple. All right, so that's the first one. Now, if I have e to the 1 over n, that is equal to the nth root of e. So to simply deal with this, if I have 4 to the half, that's supposed to be right, the square root of 4. And that is equal to 2. So if you put in your calculators 4 to the power of a half, you will get 2. Right? You will get a dose. So it just simply means whatever is the denominator will be what the root is. So here's the square root. Usually you don't put 2 here, it's understood. You usually just see square root of 4. This is understood as it has a 2 here. All right, so I just put that for emphasis. So if you had 3 to the third, let me use 27 to the third, I will say the cube root of 27, right? This here, this number is the denominator, so you put that there, and you put 27 inside, the cube root of 27. Nice, cube root of 27. This is the form it's supposed to be. So you're just focusing on the form, not necessary to work it out. I just emphasize this is 2, so you know 4 to the half is 2. But whatever number is at the bottom, that will tell you what the root is. First one is squared, the second one is cube root. Right? This general form is the nth root. Right? So let's look at the next one, which is just an addition to what we just did. Right? So we have e to the m over n. Now, rather than going straight to what they have here, I just want to do an additional step. This is like saying e to the 1 over n, put that in brackets, m. Because we know we can multiply these two and we get m over n, right? And once we know that, then we know a to the 1 over n, which is what we did just now, is the nth root of e. So we can write the nth root of e. And put back the brackets and have the m. So if I have to give an example, if I have, we use 4 to the 3 over 2. I can write this to make it a little easier based on the rules. 4 to the half cube, right? Because I know if I multiply half by 3, I'll get 3 over 2. And I know 4 to the half is like saying the square root. So I can say the square root of 4. I just put in 2 for emphasis. I can't leave it like this because you have brackets and to the power 3. So I put my brackets to the power 3. That's all. So the key thing with this question is you have to put the numerator outside of the brackets, right? So 4 to the half and put the 3 outside. And once you do that, you'll be able to simplify it, like put it in this form, right? You'll be able to put it in this form right here. All right, so that's that. Let's look at the purple. All right, so let's look at this one. 1. So a to the power 1 is equal to a. So this is simple. 2 to the power 1 is equal to 2, that's all. Right? 3 to the power 1 is equal to 3. It's just saying it's understood. You don't have to write the 1 on top. You don't have to write the 1 on top. X to the power 1 is equal to x. Z to the power 1 is equal to z. Right? You don't have to write the number. That's what it's equal to. All right, so that's that one. And we have the last one, which is a to the power 0 is equal to 1. Now, I have to prove this one because these I can just show the form and tell you how you get it. But I can prove this one. So let's say I have 2 cubed divided by 2 cubed. And I'm using this rule of indices here. When you divide in same letters or same numbers, you subtract the powers. So these are same numbers, so I'm going to subtract the powers. So I have 2 to the 3 minus 3, which is 2 to the power 0, right? So I know this is equal to that. Now, I can work out this here and say, all right, 2 cubed over 2 cubed is like saying 2 times 2 times 2 over 2 times 2 times 2. 2 cubed means you're multiplying it 2 3 times. It's not 6, right? You're multiplying it 2 3 times. And I can cancel out, right? I can cancel out. 1 times 1 times 1 is 1, and 1 over 1. So I know this is equal to that. The same thing is equal to that. So if this is equal to 2 to the power 0, and this same thing is equal to 1, therefore, 2 to the power 0 is equal to 1. So any number raised to the power 0 is equal to 1. You can put in your calculator a whole set of numbers and raise it to the power 0. Any number raised to the power 0 is 1. You get 1. All right, so if you put in a calculator 10 million, if you calculate a whole lot, and put it to the power 0, you'll get 1. So that's it for laws of indices.